Okay, testing, testing. Okay, audio seems to be good. Alright, so it has been a minute, but this is part 7 of converting a Cr10S-Pro 3D printer to a Voron Switchwire. So what you're looking at right here is the interior, the underside, if you will, of the printer. So in the last part 6, I kind of started on the whole wiring thing. Um, Pretty sure I'm either completely done or almost sort of completely done at this point. Um, at the very least, yeah, aside from like maybe one or two things. But anyway, so I could have tried to record myself figuring it out, but that just felt like it would be way too tedious. So guess I'm just going to kind of explain sort of a process, what all these connections are, um, what I was able to reuse, what I wasn't really able to reuse, and yeah, so we'll take it from the top. So this is the power supply for the 3D printer, and don't worry, it's unplugged and all that, so I'm fine. Um, but it's got, I guess, these two, which are sort of the positive and negative voltage DC outputs. So power supply takes in AC current, right, from or alternating current from the actual power cable that comes in, and it goes to N and L. So N being the negative and L being the positive. I'm pretty sure. I can double check that. This symbol right here is representative of ground, so that basically makes it so that when you do turn this on, this doesn't actually carry, like, the case itself doesn't carry a charge, and sort of other components don't actually carry a charge if you were to touch them, right? Because it's grounded. So at least I'm pretty sure. Uh, so yeah, we've got so this one, the N, and I guess I'm gonna double check really quick for sanity to make sure AC N, yeah, N is neutral, L is live, yeah, so these are correct. So moving, I guess I'll move the camera up a little bit to kind of show you the outlet, power outlet, right there, so near the top. Kinda, okay. So right here, this is the red. So this is the actual current that goes through when you flick the power switch on, goes all the way to here, and attaches to specifically this one to the L, and then you've got this one, the black, which is the neutral wire, and that goes to this one right next to it, so the N, and then the ground is the combination sort of green and yellow wire that comes from this part of the plug, like the bottom part, and then again it goes to the power supply and then down to the relay, and we'll get to that in a minute. So after those three, we've got the positive voltage and the negative voltage. So these actually output voltage in DC current to all of the, I guess, primary components. So you've got right here, this is the heated bed cable. And you've got the red and black, so you've got the neutral and the, I guess, power wire. So red goes into the positive V, black goes into the negative V. As far as I can tell, it doesn't matter which of these you choose, as long as you choose one that is um, it is one of these three if it's positive, or one of these three if it's negative. Theoretically, you could stack all of these up, but obviously that's potentially could cause something to slip out or something. But theoretically, you would be able to do that. After the heated bed, the we've got one connection that goes to the relay, one positive volt wire that goes to the relay. I'll get to that. We've got these two little ones right here that actually power the internal fans. So this is one of them for the like the exhaust. Um, this is not one of them. This is just one of the fan that cools the power supply. This is not the original one. It is one of the Noctua fans. I did a fan modification years ago on this thing. So anyway, so yes, got these, and that is about it for this. So we're gonna move this down to the relay. And the primary purpose of this relay is because of the heated bed. So, um, at least from my understanding of what it does, is it amplifies, I guess you could say, the power coming from the main board. And so I guess first off, we've got the ground that's going into the relay, as well as the just the normal power supply. So this is where it ends. You've got the one red wire coming out for the heated bed, and what I'm pretty sure this is supposed to do is the main board itself is not powerful enough. Like, I guess it doesn't send a powerful enough signal to be able to heat the bed, essentially, because of how big the bed is. Um, Pretty sure that's what this does. I'm like 100% certain that the wires are all in the right place, and this is the specifically the heated bed related one. Um, so pretty sure that's what this is for. Um, Anyone watching this that wants to maybe correct me on that, but as far as I can tell, that is somewhat accurate. Um, what is slightly concerning is I have turned this apparatus on and off multiple times. Everything seems, at least most of the stuff seems to be working just fine. One of the slightly concerning things is the heated bed does turn on by itself right now, and that's before I've like flashed a new version of Clipper, which I'm gonna try and do for this session, see how it goes. But I'm gonna do that, and supposedly maybe it's like just an automatic sort of thing with this main board, or I mean, actually it still happened when I disconnected these. So again, a little bit strange. Not entirely sure why that would be the case. Um, but it is, I guess there could be potential that the wires for the um, power cable plug or the switch are wrong, but I mean, you flip the switch, it turns on. So I'm kind of doubtful that that's the case, and there weren't any like issues other than that. So hopefully we can maybe figure that out tonight. But anyway, so that's the relay. Next up, we are going to go down to the main board, and I think I'm going to do a little bit of finagling with this camera mount. Get it. Come on. Alright, let's just do this one. I think I mentioned this before, but I did 3D print this this camera mount, so it's not most practical solution, but was pretty cool to design. All right, that's looking better. We bring this. Oh, I think that's, yeah, that's pretty good. Distance. All right, just gonna secure that in place. Move that. Oh no, we don't want to secure that one in place. We want to get that one unsecured so it can move up like that. I think that's, come on. That is a lot of drooping. Just gotta, just gotta. Oh, okay, I'm just gonna keep that like that for now. Okay, so when it comes to wiring up this, first main connector we've got is the power input. So this is where two red and the black wire from the one from the input voltage power supply and one from, well, sorry, both of them output voltages, one of them positive, one of them negative. Those two wires from there, from the main power supply, go down to the main board, and this right here is the input for that. So this is what powers the main board. And then you've got these three outputs. The first output here is the, I think this is actually for the bed sensor. So like the homing sensor that Voron has in their original, like based off of the wiring diagram that they have for this board. Um, this is supposed to power that bed leveling sensor. I'm doing something a little bit different because obviously I didn't get a kit and I'm not using the default Voron bed leveling sensor. I'm using a what's it called? The beacon, and I have like a slightly customized 3D printed part for that. Um, but that is where it would go. The reason why you're seeing a connection there at all is because I'm actually using this to power the Raspberry Pi from within here instead of having a separate connection, which is what I was for power, which is what I was using on the original sort of Voron version of this. Sorry, Clipper version with the other main board. Okay, third one, we've got the second two of three is the heat bed, and that's where the output for the relay is. So that's that. It was already talked about. Next up is the actual heating cartridge for the hot end itself. So got that installed right there. Relatively self-explanatory. Next up, we've got these two guys. So both of these are fans. This one, pretty sure is the part cooling fan, and this one is the hot end cooling fan. So these are using um, the wires that I got for this for the self-sourcing. They all came in these sorts of spindles, or whatever they're called. They are pretty flexible, so more flexible than the like standard fan wires. Like it's a lot more difficult to like bend them. So that's something to kind of keep in mind. This is, I'm pretty sure, yeah. So now we go on to the actual limit switches. So this one, because we've got a bed leveling sensor, we have two limit switches, one of them on the x-axis and one of them on the y-axis. So the x-axis one couldn't really, uh, I guess, salvage that. I mean, you could probably create a custom mount potentially to salvage that one. I didn't print that part or design a part like that, so right now we're working with the with just what comes with the self-sourcing. I should mention. I got nice. We have it here. Okay, so this is what it looks like. So I'm reusing the y-axis one that you'll find on the top of the printer, and I guess I could maybe flip this around to kind of show you maybe later. But if you can see, this is what the limit switches look like. If I can kind of get it to focus a little bit. Come on. Come. Okay, it looks like oh, did not want to do that. Looks like the camera doesn't exactly want to play nice, unfortunately. So I guess I'll kind of just explain. Okay, so on this guy, uh, on the left side, there is the letter. Oh, flip it around. Okay, so on this guy, if you see it, how this is on this side, on the left side, you have the letter C, and then on the right side, where this pin is, you have the letters NC. And so those stand for, if I can get my notes here. Come on. No, not there. Okay, yeah. So C, the letter on this side with this pin, stands for common, and NC, letter on this side with this pin, stands for normally closed. So what that basically means, so it's grounded when idle, so when it's not being pressed like this, and the signal opens when it's pressed. So yeah, ground signal. Yeah, so but basically what the gist of this is essentially why I'm kind of highlighting those two letters is it matters um, where obviously the order that they're in here. So if I can one, okay, yeah. So the side that has the C on it, so this side, if you flip it around, you've got two numbers. Kind of hard to make it out, but there's number 1 on this side and number 2 on this side. And the yellow wire here is going into number 1, and the white wire is going into number 2. Check to make sure I didn't. Yeah, yep. And so you basically gotta solder the wire onto this pin and this pin, a separate one, but you know what I mean. And you don't need to worry about the center pin. So that should be about it for that limit switch. Next one is the Y limit switch. Luckily, I was able to completely reuse the wire because the Y limiter is going to be in the same place. So that doesn't really change anything. Whereas with the X limiter, it is now sitting, instead of sitting on basically like if this is the X-axis and the limit switch is sitting on the end of the axis where the carriage is going back and forth and the carriage goes to the end to hit the limit switch, the Voron is the opposite, where the limit switch is actually on the carriage itself, and so that when the carriage eventually, bumps into the end, then the limit switch is triggered, and it's activated. So that's that. Okay, so we got X, we got Y, Z. Obviously, we don't need Z because we've got the bed sensor, the bed leveling sensor. Next up, we've got the thermistors. So this is the thermistor for the bed to read the temperature and record the temperature. This is the thermistor for the hot end. Reason it's not plugged in right now, or the reason why the two wires, which I've got right here, are not actually physically inside of the connector, is because this guy does not have like a clear, uh, one color one, color two sort of distinction. So it's kind of difficult to tell which one is which. So I'm probably just gonna like wrap one of these guys in electrical tape and then just kind of put them in there without this cover. Try it once. If it doesn't work, it shouldn't do any damage or anything. And flip them around and try it again, and then it'll work. So that's that. Next up, lights. So this is for the lights that are on the stealth burner. Did try that when it turned on. That didn't work. So maybe it's a setting that you have to configure when the firmware is actually installed on it. You've got the fan. So this one didn't turn on for like 5 seconds, and then it did turn on for a second, and then it turned off. So seems to work. Again, it's probably just firmware isn't installed on this thing. This is the part cooling fan, or the mainboard cooling fan. This is for the Raspberry Pi, this connector right here. USB, I think that's USB, yeah, USB Mini is what that's called. We've got, so those are the limit switches, fans, thermistors, power. Finally, we've got the motors. So we've got I believe this is the X, this is the Y, and this is the Z. So all three of these are reusable. Um, they aren't the exact same ones because two of these are actually technically for the Z, on the original Cr10S-Pro, because the original Cr10S-Pro, the Z-axis is controlled by two stepper motors that use lead screws to move the carriage up and down. And instead, this printer has it just has one motor doing that, and it uses um, I always blank on the term, but you know what I mean. So yeah, got that, and then finally we have the extruder motor. So it's got four different colors. I'm pretty sure this is the correct order they go in. So these are the exact same colors that the stepper motor itself has. So again, hopefully if you're following along, you can kind of be able to figure this out a little bit easier. Um, you might wonder exactly how this main board is attached to the underside of the printer when obviously it's not the main board that the printer came with. So I did design a 3D print based off of another video that I found where a guy basically had I think it was like cut acrylic or something, and he had that in here, and he just like put it in here, um, screwed it down with the couple, holes that you can use here to screw things down, and then use that to get his he was using the original Creality board, but he was also, excuse me, sorry about that. But he was also had one for the Raspberry Pi that was like over like it was a whole piece of acrylic that fit this board and that fit the original board, right? And it fit a Raspberry Pi. Um, and he also had one for the clipper screen, which is what we'll get into in a minute once I talk about the Raspberry Pi itself and sort of how the wiring for that went, because this is probably one of the more important things if you specifically want to have your Pi powered by the printer itself without relying on a second power cable. So this is the Pi. It's just a normal Raspberry Pi 4, but if you look at the power cable, you will see these two um, these two cables coming off of it. So basically, how this works is you've got in any like I'm assuming any USB cable, most likely, probably not just USB-C, but you've got the two wires again. You've got the power wire and you've got the neutral wire. So red wire, black wire. I'll let it kind of focus a little. And what you got to do is you basically just need to cut the USB-C wire, and then you got to strip it. And by the way, I guess I'll also mention if you want to do any of this, you'll basically, I mean, you don't need one of these, which is like a wire stripper that has different gauges. You could theoretically, if you had like a something that just kind of had a sharp blade on it, and you just made like a tiny incision, into the wire, like without actually touching, like just the fleshy outer bit and not the actual metal wires. And then you just kind of brought it down like that, and then you pulled it. Then you could, be able to strip the wire fairly successfully without one of these, but they are helpful, especially with these kind of more flexible wires. This is not more these kind of more flexible ones because their exterior is a lot softer. Yeah, so wire stripper, uh, and then the other thing that you definitely need for this is a crimping tool. Crimping tool. So they look like this, and you've got this one's got two, but basically all you do, and I guess I can get, I don't want to, okay, is you get one of these, which are like the pieces of metal that you actually crimp onto the wires, which then fit onto the actual connectors, which then you can connect to like a main board safely without causing a short or something. So it's kind of this tiny little piece, and you basically just kind of line it up, and I'll do this off camera to make it. So you line it up like that, where now you've got part of it inside and you've got part of it outside. And the part that's outside is the part, there we go, that's a little bit, yeah. And the part that's outside, oh, that was a good, yeah. So the part that's outside is the part that interacts with the actual like the wires that come out from the main board, or not wires, but the connectors. It interacts directly with the connector, and the part inside is the part that actually wraps around, like it bends around the wire itself to hold it in place. The exposed wires to hold them in place. So that's what you need to do. To specifically do something like this, you probably also want third thing, which is a soldering iron. I've kind of showed this a couple times. This one's like a gas-powered one, and this one is nice because it's got multiple modes, so you can unscrew the actual soldering iron tip. There we go. Unscrew the soldering iron tip, and you're left with a heat gun, essentially, and then you can actually remove this part, and you get like a little blowtorch, which is kind of cool. Unfortunately, a not so insignificant disadvantage of using gas is you have to worry about exhaust. And so this right here is basically an exhaust for residual heat. And so you basically have to worry about where that's going. It's not, you know, super, super hot, but it is kind of like a mini heat gun. And so if you have it, for example, pointed in the wrong direction, like here, it will begin to potentially melt something like this. Ask me how I know. But yeah, so basically you use that, and then you know, you can look up how to solder exactly, but you'd use solder kind of like this to solder these wires onto these exposed wires from the cut USB-C, and then you could technically use something like electrical tape um, to secure it, but I have heat shrink tubing, so you can, you know, thread that onto there, and then again use a heat gun or you could you could even theoretically just use the residual heat that comes off of the soldering iron to melt it, but it doesn't take a lot. And yeah, that's pretty much it with that. So now we move on to the actual voltage limiter, and this is what you use to prevent your Raspberry Pi from basically shorting itself immediately, because the I believe the output on the main board delivers like I think it's like 25 volts or something, but it's I think it's definitely over 20 volts, and that is way 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 too much for the Raspberry Pi. So you give it that voltage, you're gonna completely overload it and kill it basically instantly. So the way to prevent that is you use one of these voltage limiters. I think this one is you could probably pause this and take a good look, but that's the name of this one. Um, but basically, you've got input here, you've got output here. Again, you've got the red, you've got the black. You just kind of match it up, positive, negative, and then you've got this guy right here, and this is what actually turns up and turns down the voltage that you allow through. So you basically take a screwdriver with the correct bit, and you bring it down there, and I forget if you turn it clockwise or counterclockwise, but you turn it to actually lower the voltage, and then of course with this you'd need a voltmeter to actually test what voltage is actually coming out of there. And what you want to do is you want to turn it down to 5 volts. So 5 volts is the safe amount. I think I got a recommendation to turn it like to 5.1 just as a way to make sure that the Pi is getting enough power, but not all the way to 5.2 because that'd be too much for it. So yeah, so basically, yeah, you solder it onto here, solder the wires onto there, test it until the output of this is 5 volts or maybe 5.1, if that's not enough to power the Pi, and then you plug that into the Pi. So these input wires are running directly from the main board onto here, and then these two are running onto uh, here, which powers the Pi. So that's about that. I mean, for the Pi, we've got the beacon probe, uh, and we've got the just the other USB-C plug to interact with the main board. It'll be interesting to see how this system handles the beacon. I had a lot of issues originally setting up the beacon because like it wasn't basically the speed, I guess, on the cable wasn't really fast enough. Like the cable I was using was too long, and so it was causing like delayed reactions in the beacon probe, and that was causing it to like not to basically shut down and stop functioning. So that took a while to fix, but we'll see how that ends up going with this. So I'll bring it back up to here, and I'll finally talk about the uh, the clipper screen itself. So this is the clipper screen, and this is a 3D printed design that the same guy that I mentioned with the acrylic. I guess I'll probably link him at some point, but basically this goes onto here like so. Kind of get these wires out of the way, and it goes on like that, and then you screw it into these 4 holes. Now, Raspberry Pi, I might have made a slight miscalculation when I was accounting for it because, again, the guy used a piece of acrylic um, in order to put the Pi exactly where he wanted it, which was basically, he basically put it like right here, pretty much. Which makes sense because then you have plenty of room for the wires and all that. Because I didn't have that luxury at the time, although, in hindsight, it probably would have been better to just, I don't know, have somebody do it for me online. I decided to try and print it to where it sits like this, and so I've got the sort of addition that I 3D printed. So it's this. The idea is it attaches to this like so, and then the Pi attaches just like this, and then that's pretty much it. So it does, work in the fact that it's secured. I didn't think about the fact that the power outlet uh, doesn't exactly have a lot of room to work with. So at this point, I'm probably, and again, I don't have a way to 3D print another one right now. So what I'm probably going to do is just kind of have this on the outside um, as a way to just kind of compensate for that. Uh, I'll mention that the clipper screen has this ribbon cable, and the ribbon cable goes in like this. So yeah, might link that again, that other video at some point. If you don't want to, again, I mean, I probably will eventually, redesign this stuff, but for now, the wiring seems to be working. Again, aside from the whole weird kind of bed issue. And at this point, I'm actually going to see if I can flash the firmware. So, and I'm going to test it, see if it's still, if you can still hear me. Okay, test is successful. Okay. Yes, okay. How am I gonna do this? Guess I'll get you to... Alright, I'm going to move this real fast. Actually, okay. I'm gonna shut off the camera real fast. We're gonna stop. And we're still streaming, but I'm temporarily shutting off the cam. And I'm gonna try and move this as fast as possible over. I don't know if I like that. Hold on. Move that to be like that. That's pretty good. And then bring it. Okay. Keep moving. Get this guy Okay, looks pretty good. Now I just need to make sure you can't see behind. Okay, let's see how well I did. Yep. Okay. All right, just gonna move this a little bit. Woo, okay. We're gonna move that. There we go. That's better. Gonna point this down. Okay. All right. And yes, I am running Linux on this. Okay. So we're gonna. So I guess what I first want to do is get a. It's been a while since I've done this, but yeah. Okay. I will be right back. Alright, I'm back. I found it. Okay, so this I'm going to use to get the. There we go. Get the micro USB. We're going to plug it in. Okay, looks like it's detected. Alright, so now we are going to. Let's see, what is it? Haven't actually done this on Linux yet, but Raspberry Pi Imager, that's it. So this is the Raspberry Pi Imager that we're going to use. Let's try and. A little better. Okay. What for Debian Ubuntu? Yeah, okay. This is a Debian system. Alright. Yeah, you can't see my fingers. Okay, so what we are currently doing is we are installing the Raspberry Pi imaging utility, which is basically going to then take software, and the imager should. Now, is it actually here? Writable system. Okay. Is it will image the micro SD card, and it'll write the firmware to it basically, and then we'll be able to wait. Okay, actually, all right, I'm a little bit off. So you write the firmware. Okay, it's been a long time since I've done this. This might be a bit different. Um, no, okay, yeah. Yeah, okay, I remember. So you first write the image of mainsail, which is the version of Clipper we're going to be installing on this. You write that to the micro SSD. You plug that micro SSD into the Raspberry Pi, turn on the Raspberry Pi, and then you remote into it via SSH, which I haven't done on this either, so that'll be interesting. And then once you remote into that, you configure some stuff and you get some stuff set up to where you can have a web-based interface to be able to use it. And then you can which, yeah, like you don't need Clipper screen, by the way, technically. And I was getting by without Clipper screen this whole time. Little painful at times, especially when leveling the bed, but I could manage. Okay, so hopefully it looks similar. Okay, so first we've got Raspberry Pi 4, so select that, select the OS. We are going to go to other general purpose OS. Oh no, actually. Um, Other specific purpose OS, that's it. Pretty sure. 3D printing, yep, there it is. And Octopi is one of them that you can do, that you can use Clipper on. Print watch. Huh. Okay, this is very interesting for an extremely personal. Won't get into that. That is interesting. Okay. Anyway, so yeah, mainsail is the one we're looking for. Octo Clipper is the other one, and there should be another one. I think it's called Fluid, but it's not on here. Click mainsail, mainsail OS. There is a way to do this manually. Remember on the Pi, like you install Linux on it, and then from there you actually set up mainsail manually. I think I tried doing that once. It was not fun, so I would recommend kind of steering clear of that. And storage, there should only be one, 16 gigabyte. Hit next, and then yeah, we'll hit edit settings, give myself username and password. We'll just call it Raspberry Pi. I'll type that in again just in case. Okay. I mean, it doesn't really matter for anyone watching this if you're able to somehow see that. Okay, wireless LAN. This is important because this is how you can actually see it on your network. So SSID Yeah, so this is actually where you enter in your LAN's name and password. I will. I mean, I do have an Ethernet cable that I could use. Yeah, I'll just use Wi-Fi. All right, I'll be right back. Okay, I'm back. That should be correct. Set locale, sure we can do that. And that should be correct. We'll save those. And we'll check if there's anything else. We should be fine. Oh, actually, yes, we do need to enable SSH. And options. Okay, save. That should be everything. Yes. And yeah, make sure that you don't want to erase the data on this because it will be. I mean, there are ways you can get data back from doing this, but best not to risk it and save yourself the trouble. So make sure it's totally fine to erase whatever data you have on here. So hit yes, and then it'll ask for my password. Okay. So while that's writing, I think there is potentially one other thing I need to do in terms of wiring other than that one thermistor. I think the clipper screen does actually, like, it has an output or an input for some wires that probably goes into the main board. So I will need to do that. But yeah, I mean, the wiring thing is relatively self-explanatory. I mean, I don't think you'd need me to show you how to do that. It does take some practice though, especially with some of those fan wires, where if you crimp it incorrectly, it will uh, not be secured, or it won't go into the connector easily. But yeah, it's just something that you get better at with practice. Hmm. Usually doesn't take this long. Maybe it's because I'm always using the bigger micro SSD. Another challenge that I'm gonna have to kind of figure out is how the wiring is supposed to um, how the wiring from the hot end, like the carriage, is supposed to go. Because there is, and I'm not sure if you really saw it, but there is a hole on the side of the 3D printer, and that hole was like has the wires that go out to the breakout board, right? And then the breakout board then goes into and then that goes into the hole in the underside of the printer, and that plugs into the main board. Right now I'm just plugging everything directly into the main board. Like I don't have a breakout board on the hot end. I might do that at some point in the future, but now we're kind of looking at kind of like a minimum viable product type of thing. Another thing that I should mention is the linear rails that I got for the Z-axis. I got linear rails that were uh, like the longest you could get that could fit. Um, Thinking that there wouldn't be any issues with that. There is kind of an issue, specifically with like one of the rails, and it's basically I guess it's hard to describe. So there's each rail has two sort of bumpers on the end, like 3D printed like stops, so you can. I guess it's a way to make sure the rail stays in place, even though they aren't strictly necessary. I guess they're a way to prevent the entire uh, carriage from falling off the rail, basically. Uh, However, the one on one of the sides also kind of doubles up not only as a stop for it, but it also holds the key block, which is what holds the tension on the z-axis to basically allow only one motor to pull it. And that is thick to the point where there is, even if you like turn the knob to bring the bed down as far as it'll go, there's like a sliver of clearance there, which could be a significant issue, and it might require me manually kind of removing some of the plastic on that with with the rotary tool I have. So that very well might be, or I'll have to come up with a 3D printed solution and have that as one of my first prints on this. Which I should also mention, the the print that I did do to try and mimic the piece of acrylic that the guy did, uh, the holes didn't really match up at all, and I'm assuming that's because he had a different variant of the printer that he was using. Maybe he was using the V2 or maybe something else, and there are a couple subtle differences between different versions of the printer, like the one that I have. Um, it has a relay that looks like how it looks, that's kind of like a bit big and stuff. The version 2 has a much smaller one, and also this specific one, interestingly enough, it has a heat sink that it's like glued to, um, or it's got like thermal paste that holds it on there. And I remember that specifically because there were a lot of complaints about that relay specifically overheating in older models. So I didn't get the oldest, but I certainly didn't get the newest, if that makes sense. And it is still going. I will say that probably once this gets written, and then maybe I can check to see if we've got a connection to the Pi, um, I might call it a night after that. But we will see what happens. But yeah, this is definitely taking a bit. Okay, you can still hear me. While we're waiting, I also funny story about this laptop that I now have Linux running on. So of course I ran Windows on it originally for a long time. I think this is like a 2015 era laptop, but I got it in like 2015, 2016 era laptop, and I got it in like 2019, I'd say. So it's definitely showing its age in some places. So figured it was a good idea to put Linux on it. Originally, I had CashEOS on this, and now I have it on my main computer, at least in my apartment. And it's been interesting. Like there was one time when I booted up the CashEOS and the desktop was completely gone. Like the applications were all there, but the taskbar was gone, and the background was gone, and all of that was gone. Um, Apparently, it was just because the service that specifically does those things wasn't loading for some reason, and then I updated and that fixed it. So, Linux is definitely one of those things where there's there's definitely a lot more things that can go wrong, but of course it's one of those things where if it does go wrong, you can easily fix it if you know what you're doing. Whereas with Windows, it can be a lot of that could potentially be up to Microsoft and whatever they're doing with that, like with the whole CrowdStrike thing that happened last, yeah, last summer, and that whole fiasco where somebody just pushed out an update that had a bug in it that bricked every single computer that had CrowdStrike installed temporarily. Um, I actually work in IT. Luckily, I work at a university, so during the summer didn't really have wasn't a total disaster. Just had a bunch of end user devices that we needed to get that bug removed, but it was definitely a tedious process. But yeah, Linux on this guy. When I was using OBS, and it took a while to get OBS to work on this in conjunction with DroidCam, which is what I'm using for my camera, because I'm using my Android phone camera, if you couldn't tell, to record this. And so it took a while to get that to work. And once it did work, I did a couple, I think I did one successful live stream where the video quality was actually not terrible. Um, and then the next day, I try to do another one, and it gives an error saying that the video codec wasn't found. And so I go through this whole wild goose chase of trying to fix it. Um, I end up accidentally bricking the computer almost and having to like go into recovery mode, and I didn't have anything important, so it wasn't a big deal, but still, and just running the same commands over and over and over again. And then I figure out there's a different way to update the NVIDIA graphics driver, which this has an NVIDIA graphics driver, which is the main reason why there was, this whole thing, because NVIDIA drivers don't play well with Linux a lot of the time, whereas AMD is a lot more forgiving, it seems. And so, um, yeah, so basically I just had to enter a different version of the same command, entered that, and it fixed it. So, spent a long time, but learned something relatively valuable, I guess. But yeah, I guess I'll mention again takeaways when it comes to wiring. I didn't have to use. I'll mention this now since we've got some time. I did not have to use any of these guys, which are basically the plugs that plug into the other end of the power switch, like the on-off switch, and the power plug itself. So didn't have to use those, and I, in theory, shouldn't have to use them. Also, didn't have to use any of these because these are what you actually um, attach to the power supply. Those like forks, which I did not show. Taking them in and out, but I mean, it's pretty, like, it's literally just a screw that you turn to release them and then turn to tighten them. And, oh, also along in that same vein, did not need to use these thick gauge wires at all, which are the gauges of wire that you'd need to connect, specifically like the high-powered wires for the power plug, and the wires that go into um, like the 24 volt power for the main board and stuff like that. So those I didn't need. Um, I didn't need most of the smaller gauge wire, and to be honest, I had enough small gauge wire kind of lying around as like, you know, old 3D print fans and stuff that I might not have even needed it, but it's probably good to have anyway. Other things I didn't. Obviously, I didn't need to, like, all of the motor wires didn't need to swap out. Um, Only things I did, I guess, were the fans, the light, one of the thermistors may or may not be the case depending on the type of hot end that you go with. And the motor. the extruder motor. And then as well, and also, Raspberry Pi and all of that related stuff as well. So definitely a lot less in the way of purchases than you normally would need to do. Although, does that make this worth it? That's definitely a question. Although I did relatively recently look at listings for this printer, specifically of like it being inoperable, and they're not bad. Like I think it saw one as low as like less than 100, which I mean for something this big is it's a pretty decent deal. Like, I think you can get this new still. I think Reality is still selling this new for well over $500, which is just, with the competition that they've got nowadays, is just kind of insulting. So, yeah, whatever you do, yeah, I definitely wouldn't recommend getting one of these new. Like, if you want to get a really big printer, um, and even if you want to do like a modification to a Switchwire, there's the Cr10, and maybe even the Cr10S that are way more bare bones, probably significantly cheaper, um, and just easier to work off of in comparison to the Cr10S-Pro, which has this sheet metal frame, which looks nice, yes, but that also means that you're a lot more constrained with what you can work with. And of course, there's the ender wires, which I've seen. Like, that's a fairly common Voron conversion that people have done. 99%. Almost there. Okay, this should be significantly faster, in theory. It is strange that it is taking this long, but... Oh, it's probably because I'm live streaming on this, duh. Guess it's the equivalent of running Blender in the background. Hmm. Let me think of other. Guess there's another bit of kind of just bit of information I realized. There is, so you know how of the different 3D printer hot ends, there are different types of nozzles to go with different hot ends, right? So I had a micro Swiss all metal hot end that I used on the Cr10S-Pro, and I ended up getting a Diamondback nozzle for it. And Diamondback is basically like the very tip of the nozzle is made of, like, I guess an artificial diamond type material. Point of it is it's extremely conductive and it's extremely hard. So you've got the best of both worlds where you don't have the steel nozzles where they're very durable and they can take abuse from uh, tougher plastics than PLA, but they also don't heat up well and they don't change temperature as quickly as the brass nozzles, which can cause issues. But the brass nozzles are, more prone to being uh, like suffer degradation over time from plastics, and so that can also cause issues. And so Diamondback nozzle is basically meant to be the one nozzle that you can get, and it basically lasts forever, and you can throw anything at it because of that core within it. Um, so got that. I didn't realize at the time that the version of that nozzle pretty much only works with the micro Swiss, like heater block and heatsink combo, and it doesn't really work with anything else. Whereas like the M6 nozzle, which is the one that works on the or no, the E3D V6 nozzle, which works on like the E3D V6 hot end and a bunch of other hot ends. Um, and there's probably like one or two others. So it definitely can lock you into the micro Swiss. And I actually did do a redesign of uh, the Voron Stealth Burner with that micro Swiss heatsink heat block combination in mind. Um, and I did print that, and then I lost a bunch of data. Maybe not permanently, but it'll take a ton of effort to get that back. And my 3D models were in that, and so that was one of them. So yeah, I don't know if I'm going to be willing to redesign that. Did take a fair amount of time, but we'll see. I'll have to redesign most of the things that I did print anyway with this. All right, come on. We're getting there. I also have another 3D. I do technically have another 3D printer, although it's not in a state of exactly operability right now. It's actually the first one I ever got back in, I think it was 2017 or like Christmas 2016. It was the Monoprice Select Mini, and it was an interesting one. Not exactly the most mod friendly, at least in terms of like the software. Like there were at the time there were a lot of hardware mods for it, um, but it is definitely a dinosaur of sorts when it comes to 3D printers. Like you had the one fan that literally doubled as the um, part cooling fan and the uh, the hot end cooling fan. So, and it had like two ducts that separated it. Needless to say, the part cooling was subpar, and there were like mods to fix that and all that. Which I did try to kind of get into, and then I moved, and then stuff happened, so I kind of just have it kind of taken apart right now. Thinking of maybe like converting that into something would be kind of cool. But for now, I'm more concentrated in getting the workhorse back up and running. Three, two, one, and done. Okay, there we go. So now I'm going to remove that. And I'm going to plug that into the Raspberry Pi. I guess we'll test it the with the printer. So I'm going to get that. I mean, I'm just going to plug in the Pi for now. And before I turn the printer on, I'm going to disconnect the two heated bed cables because I do not want that bed heating up while the printer is on, because it can get that could cause like runaway problems and other stuff. And of course, you know, worst case scenario, a fire, so don't want that to happen. Get those out of the way, alright. So now we're gonna plug in the printer and switch it on. Alright, Raspberry Pi is on. So the regulator should be working. I'll double check the bed to make sure it's not. Shouldn't be possible for it to warm up, but just in case. Yeah, I'm not feeling anything. Okay, that's good. Alright, so now the Pi is on. The green light for internet is showing, like the green light is blinking. So Pi has the red light for power, green light for internet, which basically like internet, like I think it's basically pinging, it's able to send a signal out. So now we gotta figure out what that IP address is that it created for itself. So I usually have like an IP address finder tool that I used for this, but let's look it up. This Linux Kate. Addresses. It's on network. There we go. Gotcha. That is a bit of an annoying thing with Linux I've found, is that you've got to do the copy and paste without, no, that's not what we wanted. The copy and paste without doing the keys. Okay. So we're currently connected to Ethernet. 192.168.1. And that's, so subnet would be 192.168.1.0. So, I mean, basically this. Double checking to make sure I didn't screw that. Yeah, no, that's right. Nope. Oh, okay. Then let us do that. I can't use the keys. It's a bit of an annoyance. Okay. Go, yes. Okay. Go try this again. Business gateway. Mainsail, Alex, Pop OS. Okay, so that's the router. That's the laptop. That should be my main computer. Mainsail OS, okay. That's it. Okay, Linux. Two. Enable SSH, yeah, so we've already enabled SSH. Yep, found the IP address. OS system, okay. Yeah. Okay, that's nice. So we can do it directly here. So we're going to paste that. And we are going to change this to 192.168.1.21. Fingers crossed that this works. Yep, okay. Okay. Yes. Alright, looks like it works. So for the default password for Raspberry Pi should be raspberry, so that is RASPBERRY, hopefully. Okay. Hmm. Don't have caps lock on. Oh, that's why. Oh, that's why because okay, okay. I know what happened. Okay. I set up my user account already, so it should be Wortley. Come on. Hmm. Hold on. Hmm. And we can try it with Pi and then enter my. Okay. Uh, if that's the case, then I'll probably have to do this again, but for the sake of this tutorial, it was a success. So we were able to get mainsail on the Pi and then have the Pi boot up and be discoverable by the network. Um, so one of the uh, one of the things, yeah, have it be discoverable by the network. So when it comes to doing this on Windows, you can use a scanner in order to find the IP address if you want. And yeah, so guess that's going to be that for now. I'll shut off the cam. Actually, we'll shut it off this way. But yeah, when we get back, I'll next time I'll figure out what was wrong, get that fixed, and keep going from there. Get mainsail properly configured on that, and get it sent over to the and get the actual. Also check the bed really quick. Yeah, it's not warming up. And flash the firmware onto the main board. I'll show how to do that. Yeah, so that'll be next time. Till then, I will see you later.